So what we're going to do today is move on to systems of equations with three equations. And if you have three variables, you have to have three equations, okay, to have a unique solution. Now, these still have one solution, or infinitely many solutions, or no solutions. Before when we did that, I hope you're writing while I'm talking. Before when we did it, we had just lines, yes? But when we have an x, y, and z, we actually have planes. So they can be the same plane, they can intersect all at one point, or they have no solution because they just don't all intersect at one point. So this method that we are going to do today is the most efficient when you have three or more equations. When you only have two equations, elimination substitution is the most efficient way. You can use this method no matter what, but it's just not quite as efficient. So what we are going to do is we're going to use the fact that we can rearrange any row or any equation. We can multiply any equation by a non-zero number. And we can add two equations together and replace one of them, and it's the second one. I'll talk more about that. And the goal of doing this is when we're done, we want to have something. How about I get a pen? Something that looks like, that's horrible, x, blah, 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 equals y, blah, 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 equals, and z. So when I'm done, I want to have it nice x, y, z. Do you notice 1 is the leading coefficient of all three of those? Positive 1. Okay? There's no x's over here to mess with. There's no y's in the third one to mess with. Okay? It gives us a cleaner slate to start going back up with our answers. We'll have an answer for z, then we'll plug it in and get y, and then we'll plug both of those in to get x. So we'll use those procedures listed there to accomplish that stair step. 1 is the leading coefficient. To have a nice equations that I can plug back in. Now I said nice equations, I didn't say nice answers. We will not always get whole numbers. Okay? We still can have infinitely many solutions. We still can have no solution happening. Okay? So once you get that written down, our system of equations we have is 2x plus y minus z equals negative 10. Negative x plus 2y plus z equals 3. And x plus 2y plus 3z equals 13. The biggest mistake people make here is they don't write the problem on their paper. They try going, ooh, let me just do it in my head. No, write the problem on your paper. Then, before you do anything else, look back and make sure you wrote it correctly. I do not know how many times people have come in and said, I tried this problem 3 times and it doesn't work. Okay, if I put a positive z in the first equation rather than a negative z, I can get an answer. Am I going to get the answer the book has? No. So make sure you wrote it down correctly. Taking a second between steps, making sure you transferred from one step to the next will save you a ton of time in the end. And I love how a lot of you say, I never show my work. So you better not show your work. This is an operation that a lot of it is done in the background. You write down what you do, and that's it. You write what you do, what you're going to do, and the result. You don't show how you got there. Because everyone in the world should know how to add 2 plus 3, correct? Okay, so this is what I want at the end. I want x, y, z, yes? I want x with a leading coefficient of 1. Do we have an equation up there that might be valuable to move up or down?
Well, x is going to be equal to 13 minus 2y minus 3z because there's no...
I have the bottom equation, yes? Do you see that? 1 is the leading coefficient. Would that give me already to this what I want to see?
Yeah.
If I moved it? Okay. So how you do this I showed you my paper. It's one big column, and I worked down. I would highly suggest if you're going to be a person that tries to work across, fold your paper in half, because I fold my paper in half, and I do every single problem like this. Okay, so what we do is we write our set notation again, and we just say R1, arrow R3. Okay, I call them R because these are rows. Yes? The equations are rows? And going down are columns. So I just call them, that just tells me I'm switching R1 with R3. Pretty simple, right?
Yeah.
So guess what I did? I switch R1 with R3. So I have x plus 2y plus 3z equals 13. I didn't do anything to row 2. And then I have to get all of row 1 down to the bottom correctly. Last hour, I put a positive z right there, and it messed it all up. Take a second to make sure you moved everything in row 3 up to row 1. And you moved everything from row 1 to row 3, and you didn't drop a negative or whatever. It shouldn't take that long to do that, should it?
No.
Take the time. So, other thing helpful, actually have to be, is it has to be in the same order every equation. X, Y, Z. Okay? If there's multiple variables, they have to all be in the same order. It is very helpful to line up all the X's, all the Y's, and all the Z's. Even if there's not a Z there, move it so they're all lined up and just leave a blank. Or you could put 0Z if you would like. You don't have to on these. So I have my first position, great, wonderful. I need stair steps, yes? I need here open and here open. The way you do it the most efficiently, because you can do it all over the place. I've worked with books that start just doing all sorts of things. And by the time they're done, I'm like, why didn't you just work across and have a progression? Because you do so many more steps, okay? So we are going to clear this first column. Anytime we want to clear the first column, because I want those to be zeros, I want those to be gone. Anytime you use the first want to clear the first column, guess what row you use? The top one, row 1. If I want to clear column 1, I want to use row 1. If I want to clear column 2, I want to use row what? 2. If I want to clear column 3, I want to use row 3. And just work your way across. So what you do is I like row 1, yes? So I'm just going to rewrite row 1. I am not changing row 1 in any way. And this whole process is elimination. If I'm going to zeros, I'm eliminating, yes?
Yeah.
Okay, so we use elimination the whole process, and at the very end we use substitution. So what would I do to this x right here in row 1 to get rid of the x in row 2?
Nothing.
Nothing but do what to the 2 rows? Add them. So I'm going to write R1 plus R2. And the only row that's changing is that second row. The only row changing.
Okay.
You also put X after 0, that's supposed to be Z.
Oh, yes, that should be a Z. Thank you. Oh, and that's huge. And I would suggest your Z's start getting lines through them so they don't look like X's, or 2's, not X's, 2's. So what would I do? I'm not going to do it yet. I'm going to do it in a second. What would I do to the X in row 1 to eliminate the X in row 3?
Multiply by 2.
Not just
Negative
2, negative 2. So negative 2 R1 plus R3. Okay, so this is how this works. This step up here is what I started with. This right here is what I did to get what I end up with. I never show, it's like magic. Poof. So this just says R1 plus R2. So I come up to the previous step and I add what I have. So X minus X is what?
0.
0. You can put 0x or nothing. I choose to put nothing. I have 2 plus 2y. 2y plus 2y is what?
4.
4y. 3z plus z is
4Z.
4z. 13 plus 3 is 16. So now I'm saying I'm going to take row 1 and multiply it by -2 and add it to row 3. This is where it comes in your head. If you see my paper, you will see lots of dots because I'm keeping my brain where it needs to be. So -2 times 1 is -2. -2 and 2 is what? -2 and 2 is what? 0. Okay. -2 times 2 is what? -2 times 2,
-4.
-4. -4 plus 1,
-3.
-3. Because right here I'm saying I'm multiplying R1 by -2, yes? Okay. So then I go to the Z. So -2 times 3,
-6.
-6 minus 1,
-7.
-7. Got one more number to do, right?
Yes, ma'am.
-2 times what? 13 is what?
-26.
Okay, and you will see me write once in a while numbers off to the side, but not in the procedure. Got it? If you need to keep track and write it off to the other side, you can. So I got -26 and -10, -36.
Wait.
You notice I wrote nothing on here.
Yes, ma'am.
You cannot. You can do the sides, but you cannot mess with the work going down.
Okay.
Okay, I'm going to rewrite this over here because it's looking gross.
Yeah.
Because we need to just
No.
make sure we're doing what we're supposed to be doing.
Yeah.
Okay, so we need Y, we need, how about we don't need Y?
We need X.
We need X, we need Y, and we need Z. Yes?
Yes.
Okay, 1 says leading coefficients. At this step, I either get a 1 here at the Y, or I work on getting rid of this Y. Either of those two steps. The reason I say either one of those and not one over the other is this 1 for the coefficient of Y, if I can divide my second row by one thing and get nice, neat answers, I do it. Dividing makes numbers smaller, right?
Yes, ma'am.
Yep.
Oh.
If I can't, I leave it alone. I'd rather work with bigger numbers and fractions. How about you guys?
Yes.
Yes. Okay. Now, I said divide, but is there divide anywhere on my list of things I can do?
No.
No. So we can't divide. We have to multiply by the reciprocal. Okay? So what would I multiply 4 by to get 1?
4.
What?
4.
A fourth. Okay, does 4 go into every other term in the second row?
Yes.
Yeah, so could we multiply by a fourth right now and get some smaller numbers?
Yes.
Okay, let's do it. So we're going to take 1/4 R2. And you notice, where am I writing this? Right next to what?
So
What's changing. Always write it right next to what's changing.
I have a question. Okay, so why are you doing it to the 4? Is it to make that smaller?
Well, it's to make it 1 because I ultimately want a leading coefficient of 1 and it works. So do it. Okay, but like I said, if I had 4, 4, and 7, I don't want 7/4 to have to deal with. I would leave at the 4 and work on eliminating. And that would be where I have to multiply both by 2 things. Okay, so I didn't do anything to the first row, so I just do what?
Write it down.
Write it down. What do you notice about all of my rows and columns? What are they doing? Are they lining up?
Yeah.
Yeah, you should work on that because when we start doing matrices, I make you do that. Okay, so 1/4 of 4 is
1.
1. 1/4 of 4 is 1.
1.
1/4 of 16,
4.
4. And I didn't do anything to row 3, so I just rewrite it. And take a second, make sure you wrote it right, make sure you didn't drop a negative or A 7 turned into a 1. That's why I crossed my 7s. Okay, so I need to get rid of this y in the third row, don't I? So it's in what column?
Or
Nope.
second.
Second column, so I use what row? Second row. Now, I've had people go, well, look, I have a 3 in the first row. Why not use it? Why wouldn't I use the first row, this row, to get rid of that 3? What would I put right back in it?
3.
I'd put her x right back in it, wouldn't I?
Yeah.
Because I have to combine them. So that makes no sense. It's going to give me more work. Okay, so what do I need to do to this y to get rid of that
Multiply by 3.
negative 3?
Just 3.
Just a positive 3. So 3r2 plus r3. Am I changing row 1 or 2?
No.
Nope. So just write them. That's where I get to do my imaginary work now. Okay, so 3 times 1 is 3. 3 and negative 3 is 0. If you don't get 0, why are you doing it, right? So go back and check your work. Then 3 times 1 is 3 minus 7,
4.
negative 4. 3 times 4 is 12, and you can write it over here if you need to. 12 minus 36 is
Negative 24.
oh, I forgot my z on my 4.
Yeah.
Negative 24. So do I have my stair steps accomplished now?
Yep.
One thing I need.
Leading coefficient.
Leading coefficient on my z of what? 1. So what do I need to multiply negative 4 by to get 1? Positive 1. What?
Positive 4. No. Negative 4.
Negative 1/4.
Oh.
And hopefully I can squeeze it in. Now do you see why I said start at the top of the paper?
Yes, ma'am.
So z equals what? 6? Okay, now that I have z, I can use back substitution. We call it back substitution because we go where? Back up. Okay, so I have z equals 6. So that makes y equal 4 minus z because I'm moving the z to the other side, yes? Everyone following? I'm subtracting. This z has to move over here, doesn't it?
Yeah.
So 4 minus z, but what is z?
6.
6. So y is what?
Negative 2.
Negative 2. I know this is squished. Now I'm here for my x, right here. So x is going to equal 13. And I have to subtract my 2y over, don't I? Okay. Subtract 2 times, what is y?
4.
Negative 2.
Negative 2. And I have to subtract my 3z. And what's z? 6. So I have 13 plus 4 minus 18. So 17 minus 18 is what?
Negative 1.
Negative 1. So I have x, I have y, and I have z, and I write it in what's called an ordered triple of negative 1, negative 2, and 6. X, y, z. Yes?
Okay, can you, so after you did negative 1/4 by R3,
Mm-hmm.
and you went to find your y,
Mhm.
can you start right there again, because that's where
Okay.
I got lost.
So I have y plus z equals 4, yes? And so I have 4, and I'm going to have to subtract my z over, because it's plus z on the left.
Yeah.
So to move it on the right, I have to subtract it. So I'm going to have 4 minus z, and z is 6.
this is when you went through and solved all the rows.
Yes, I'm going back, substitution, I'm going back in and solving the rest. And then I went and I moved everything else. Because my answer was x plus 2y plus 3z equals 13. And y plus z. Okay, if you're not focused on this, you need to be quiet so other people can. Okay, and then y plus z equals 4 and z equals 6. So I just substituting, I got my answer for y was -2, and then I substituted in my y and my x, my y, my z, to find my x. Some people like to substitute and then move over. Is that okay to do? Yes, I personally just move it over while I'm substituting. Either one is fine with me.
Okay, can you, like, in the open space you have right now, can you find your, with the y and the z, can you find your x so I can write that note down?
I did right here. So I gotta move this and this over, yes? So x equals 13 minus 2 times y minus 3 times z.
That's how you found.
Yep,
Oh,
I
okay.
moved it over while I was plugging in.
Okay, so next time, that one was
No, the x didn't move. I just moved everything else to the other side of the equation. Because I want just x. Okay. So you can plug it in. I have people that like to do this. They do the -4 plus 18 equals 13, and they subtract 18 and add 4, and you still get what? -1. I don't care what order you do it, just do it right.
And then you do your final answer.
And then you do your final answer as an ordered triple.
that is a lot of
Okay, it's a lot of work, but it's a lot less work than what you would be doing randomly if I just said solve it. Because if I told you just to solve this system of 3 equations, hopefully that you're all writing down while you're waiting for me to stop talking. Okay, new column. Okay, if I ask you to solve this, you would have to take 2 of these equations and eliminate a variable, and then substitute it, and then substitute in the other one, and then eliminate another variable, and then substitute back in, and you'd have this big mess. You have this big circle mess on your paper. This organizes it straight down. Everyone could pick up your paper 2 years from now and know exactly how you got that system right there. You are going to know. When I ask you tomorrow, what did you do? You're going to say, I took -2 R1 and added it to row 3. Now, is everyone going to do the same thing in the same order?
No.
Not always. And so when you ask for help, I'm going to say, what did you do? Because I don't want to pick up where I did if you didn't do the same thing. Okay, do you want to move anything on this?
No.
No. Why would we? Yes?
They're all
Because we want what? What is our goal?
good.
X, Y, and Z. Yes?
Yeah.
Ones is a leading coefficient. I got all ones as my leading coefficients, don't I? Okay. Now, even if I didn't, like if I had a -1, I'd probably weigh against, well, do I want to just multiply by -1 or do I want to move it? It doesn't matter. Okay? Your choice. So, since we aren't going to move anything, we want to start by eliminating what column?
That's true.
First column. Not 2 columns, that's 1. First column, so I use what row? First row. So I'm not changing the first, so I'm just going to rewrite it. I have done that forever because then I tend to just leave it alone. If I don't rewrite it, my brain wants to do something with it. And I'm using it to change the other 2 rows, so I can't do anything to it, can I?
No, ma'am.
You cannot, I have some people that try to like multiply by 1/2 and use it in the same row. No, you can't do that. You can multiply times 1/2, and then in the next step you can use what you have to change. But you can't multiply, you can't change something and use it to change something else in the same step. Okay? Now, question you're asking yourself, what do I need to do to this x in the first row to get rid of the x in the second row?
Times a negative 1 or
Times it by negative 1. So I'm just going to write negative r1 plus r2. Okay? And it doesn't matter if you wanted to work that out on your own. I personally like to finish my steps and then do my math. That's what I personally like to do. So then I say, well, I want to get rid of the x in the third row, so I need to use that x in the first row. So what am I going to do to the first row to get rid of the third row?
R1 times R2.
Negative r1 plus
R3.
r3. And we're saying rows, but they're equations, right? But are they in the rows?
Yes, ma'am.
Yes. Okay, so we've got to multiply by negative. So negative x plus x is what?
0.
Zero. Ooh, that was easy. Negative y minus y.
Zero.
Negative.
2y?
Negative 2y.
Yes.
Negative z plus z.
0.
0. Negative 3 plus 1.
2.
Negative 2.
Negative.
Negative 2. You guys gotta be careful with your negatives and positives because you're gonna screw it all up. Okay. Negative 1, or negative x plus x.
0.
Negative y plus y.
0.
0.
0. Oh, this is gonna be nice. Negative z minus z.
2.
Negative 2z.
Negative 2z. And then negative 3 plus 2.
Negative 1.
And I'm serious, guys. If you look at my paper, there's a bunch of dots on it. That's what I do. I do exactly what I'm modeling here on my own paper. This one was really nice to us, wasn't it?
Yeah.
So, I got my stair steps already, don't I?
Yeah.
So now all I need is my what?
Your leading coefficient.
My
of
leading
1.
coefficients to be 1. Do I need to do anything to the first row?
No.
No. So x plus y plus z equals 3. What do I need to do to the second row? Multiply it by,
Negative or positive 2.
nope,
Negative
2.
negative 1/2. I have a negative, so I need a negative, yes? And then just the reciprocal. If that number right there was 3/4, I would multiply by what? 4/3. I need 1. That's all I need. Okay, what am I going to multiply the third row by?
Same thing.
Same thing. Negative 1/2 R3. So I get y equals 1. And I get z equals 1/2. That's what I get. How about you?
It is.
There we go.
Okay?
Yes, ma'am.
So this one's really nice. Do I even have to substitute to find my y?
No.
No. Because it's just y equals this. There's no z to have to plug in, is there?
No.
So all I need to work out is my x.
Yep.
So x plus y plus z equals 3. Well, this is 1 is 2/2, yes? So 2/2 plus 1/2 is 3/2. I might as well make 3 into what? 6/2. And now I need to subtract, right? And I get what?
3/2.
So x is 3/2. Am I done?
Nope.
Nope. Order triple.
Wait.
So 3/2, 1, 1/2.
Why can't you get into the pressure?
So you can solve it with
Because I have to solve for x. And x plus 3/2 equals 6/2. I have to subtract. I got to follow my basic algebra.
Wait, how do you get 3/2?
6/2 minus 3/2 is 3/2.
How'd you get 2 and 2?
Because you got to have common denominators with fractions. For this was a 1, so I have 2/2. 2 plus 1 is 3. And 3 has to have a common denominator, yes?
mine.
So it'd be 6 halves. Isn't 6 halves 3?
Yeah.
Yes.
6 divided by 2.
I'm counting
I don't know why, but I'm lost right now.
I don't know where
It's
the one
simple,
is.
but I'm.
You're like me. You're thinking.
You guys just have to get your brains used to working with some fractions.
No.
So you didn't write R2 or R3 at all. You just wrote.
Because R2 and R3 are there. They're
Yeah.
like done.
I know that.
I wrote them right here. I had x plus 1 plus 1 half
Okay.
equaled 6. Or 3. Whatever it equaled. 3.
Okay, that is what I needed.
It was there.
Alright.
Then she changed the one.
I
Yeah.
changed the 1 to 2 over 2.
2 over 2. So we're
On my paper, 1 would have never shown up. It would have been immediately 2 over 2. Why? Because I have a fraction anyway. 3 would have never been there. It would have been 6 over 2 because I'm going to have a fraction anyway.
Yes, you have to do 2 over 2. Because 2 divided by 2 is 1.
Yes. You have to have common denominators. No way around it. Okay.
On your own.
No. Not
Okay.
really. 2x plus y minus
Hey,
2z equals 3.
Ow!
I'm going to share this video with Mother.
What video?
The one I'm making right now.
That's fine, do it.
Are you writing this problem down?
I'm about to before I hit my hand.
Okay. X minus 2y plus 7z equals 12. 3x minus y plus 5z equals 10. I would highly suggest not starting in the middle of your paper. Where did I tell you to start? Right, you have a whole column. Put it right over here. Do not start this in the middle of your paper. Why?
That's it's such a long problem.
You're going to have to go up top, and when you go up top, you're going to leave a negative behind or a coefficient behind.
Yeah, I did.
Okay, I sometimes have to go back up top. My paper doesn't continue. I have to up here.
My paper does.
No, go to the other column. Okay,
My paper
so
does.
we want this to be x, right? Y and z. That looks like a G, but it's a Y. So, is there anything that might help us out to get towards that without doing a lot of work? Yes.
If you put R2 and switch it with R1.
If I took R2 and switched with R1, I would have 1 as the leading coefficient, wouldn't I?
Wow.
Okay.
Stud.
So just put R1 switched with R2. And this one doesn't matter. Like the other ones, we're only changing the second one. Well, here you changed both rows, so it really doesn't matter which one you do. So you have x minus 2y plus 7z equals 12. And 2x plus y minus 2z equals 3. Do you now see why I put bars on my z's?
Yes, ma'am. My twos are the whole.
He has a loop in his twos.
Oh, okay. That
Sometimes I do and sometimes I don't. Okay, so we've got that. Sometimes we can do that, sometimes we can't. Sometimes we just have to deal with the numbers we have. Sometimes you see, oh, that whole row is divisible by 3. Let me do it right away.
Yes.
Okay. But we didn't have to here. So, goal is to eliminate column 1. So what row do I use?
The first.
Row 1. Okay, so I'm not changing row 1. So x minus 2y plus 7z equals 12.
Multiply row 2 by negative 2.
Not row 2, row 1.
Oh, yeah.
Okay, so Ethan just said he's going to multiply row 1 by negative 2 and add it to row 2. Does that give me 0?
Yes.
Okay, so negative 2 R1 plus R2.
Zero.
And then what are we going to do to row 1 to get rid of the 3?
Pounded by
Negative 3.
Negative 3 R1 plus R3. Okay, would you like to try to do those two on your own?
Yes.
Yeah.
Okay, you try to do them. I'll give you a head start.
Said you were going to multiply R1 by.
We're going to
negative
multiply
3.
R1 by negative 2 and then add it to row 2.
Okay, and then what's the step after?
Then multiply row 1 by -3 and add it to row 3.
Okay, so we're times -2 times the first row, right?
Yes.
Yeah, how'd you get 5?
I multiplied correctly.
I did it right. Sorry, guys.
You guys look how I got 5 and you didn't. Because I bet you I'm right.
-2 times 2.
-2 times
-2 times 2
And then you add
equals plus 1.
-2 times -2.
The coefficient's 1 in front of the y's.
Why would it be plus 1?
Because there's a 1 in front of the.
Because there's a 1 in front of there.
Oh, plus
I love that. Because I multiplied right.
You made some call.
Hey.
Hey.
Okay, you guys need to be more careful with what? Your positives and negatives.
Yes.
I did it right.
Okay, who did it right? Good
I did it
job.
right.
Oh, I did.
Good job.
Guess who
Good
didn't
job.
I don't understand it at all.
Yeah.
Guess who didn't?
So,
I didn't
If you didn't do it right, find your mistake.
I don't.
I might find it.
Okay, this is listen. -2 times -2 is 4. 4 plus 1 is 5.
Why would you?
Because Wakanda.
Okay.
This is so like this messes with my head.
Because Wakanda.
Okay.
Yeah.
Wakanda.
So,
What you want?
okay. If you make a mistake, I'm going to tell you you didn't multiply a negative times a negative and get a positive or something silly like that. It's usually very basic math that messes you up. So check your work. Okay. Now, I finished out my first column. I need to move to my second. Neither one is divisible by anything nicely, is it? So I need to get rid of this 5y in the second column, so I'm going to use the
Second row.
second row. I'm not going to change the first row in any way, am I?
No man.
No.
So write it down. Am I going to change the second row in any way?
No man.
No.
Write it down. Make sure you transfer the correct numbers. Okay. We should have time to finish this. Keep on track. Okay. What are we going to do to the second row to get rid of the 5 in the third
Negative.
Multiply by
row? Negative.
Negative row.
Negative row 2 plus
row 3.
row 3. So negative 5 and 5 is
0.
positive 16 and negative 16?
0.
0. That would be a positive 21 and a negative 26?
What are these zeros, Z?
It's just 0.
That would be.
It would be negative 5?
Yeah.
Yes?
Yeah.
Can 0 equal negative 5?
No.
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 Wait.
Filter.
So when
But
you're
we're not done yet.
What?
What?
Okay, what?
So when you're
Zero.
adding like when you're adding negatives.
No, I have a negative right here. So it made that a negative and that a positive.
Okay,
And
now
21 a positive.
Yes.
where's
Okay,
the
that's
Okay,
That's
now,
right.
no, we need to finish.
You have forgotten your Z.
No, I haven't. 0 times z is 0.
Oh, okay.
Okay. So, what do I have to do still?
You still have to solve
Alright,
for
wow.
y.
Okay, what do I have to do to get that to be 1?
0.
No, that would make it 0. You can't multiply by 0.
Multiply by
Negative
1/5.
Oh.
Okay. R2. Now the answer here is no solution, but you have to finish. And why is it no solution?
Because
Because
there's
there's
zero
a-
down.
Equal -5.
Okay,
Uh,
and we're going to have some fractions going on there, but you know what? We don't have to do anything with them, right?
Oh.
On this one.
Wait, why? Why?
You heard that, right?
No.
I said on this one.
What?
Okay, You only have 4 problems tonight. Why do you only have 4 problems tonight? Because they're, well, hopefully not 30 minutes.
Well, the first one took 50.
Well, the first one was explanation, and it didn't take 50
It took 50.
I think it
Why
looks
would
like
it be
20.
16 over 5?
because I multiplied by a fifth.
Quick,